Now, note that line segments are not the only things that you can split in half. You can also bisect angles here. Now, again, as you can see, splitting an angle in half is going to be a little bit different. All right. So I have something that looks like this here. So maybe we can go back to our original picture. Right? If we go back to our original picture here, if you recall this, we notice that something very important here. So notice that we showed that the diagonals of a rhombus, they did a lot of things here. In particular, first of all, it's perpendicular, so it creates a mid. So they're perpendicular here. They also split each other in half. But another property of the rhombus here is, wait a minute, what's the last property of rhombus here? Another thing that we have here is that the diagonal CC1 bisects angle AC1B and AC2B, right? Now, this is the most exciting part here for us because, hey, wait a minute. By doing this is something we know how to do already, by constructing a rhombus. And in doing this, we've actually created ourselves an angle bisector. So this red line is an angle bisector here. So if we can somehow get this picture to show up in here, we're in good shape. So again, let's go ahead and do our let's go ahead and take a look at it in terms of, all right, what would happen if we tried this on a different situation here, okay? So we can go ahead and sketch our angle here. So here's D, E, F. So we want that picture, we want the rhombus to show up here. So the most important part is that we have to make sure there's a rhombus. So we have to ensure that DE is congruent to EF. And again, our goal, which I'll draw in purple here, is going to look something like this. And we want this to happen, right? So all we need to do is make sure that we can get a rhombus to show up here. So if we can get DE, so DEF, as long as we can get them to be, and G is going to be somewhere up here. So we want this. Now I know that this is a really awful drawing here, but again, this is just an imagined picture here. We want this to be a rhombus. So we want this to happen here. So we want to have a rhombus like this show up. So constructing DE and EF is not going to be too hard to do here because we know that in this situation, by constructing DE and EF here, we can just make sure that DE and EF are the same length. That's not hard to do because we can just sort of create a circle like this that passes through these two. Now, we have to ensure, however, that when we do that, we also have to create DG and GF being the same distance as well. Wait a minute, I think I know how to do that already because, all we know is that DG and GF are the same distance here. We can do that by constructing equal arcs, right? I can construct an arc like this here and an arc like this here, centered at each of the places. And it's going to look something like that here. So now we can kind of do something that looks like this here. If we can sort of generate that picture, we're going to be in good shape here. So with that in mind, let's actually go ahead and do this here. So now we can actually kind of put this together. Now, the one important thing about this construction here, ladies and gentlemen, is that even though I have D and F here already, there's no, in order for us to make this a rhombus here, we have to ensure that DE and EF are the same length. It's possible it could be already, but it doesn't have to be. So we have to be kind of careful about this here. So in order for this to work, is we need to ensure that we create the rhombus, which means that we need to have these consecutive sides being congruent here. So I'm going to do this by constructing a single arc. So we're going to create an arc like this here, surrounding point E. Like that, okay? So this here, as you can see, ladies and gentlemen, this is going to be step one here. And when we do that, we create two new points here. So let me call this here, I'll call them D1 and F1 here, right? These two, by doing this here, we guarantee ourselves that D1E and F1E are the same length, which means that we can kind of we can get our thing like this together, okay? Now, notice what's happening here. Notice what's happening here. If we take a look at this, if we look at this, D1, F1 is just the diagonal of our rhombus here, right? The diagonal of our quadrilateral. So all we're doing here is trying to find the midpoint of that. And wait a minute, I know how to do that already because that's something we've done before. So the nice part about this is that now this comes down to, okay, can I split D1, F1 into two congruent pieces? And I know how to do that. That's something we just covered. So now we can go ahead and do this here. So in this situation here, notice that in this case, 1 is going to be any radius we want here. And then in this situation, now it's just a matter of going ahead and splitting D1, F1 in half. So the nice part about this is that you can use whatever radius you want here. I'm going to use the same radius so that we have our rhombus thingy going on here. And then we can kind of do this. So I'm going to go ahead and construct an arc here. So we know that the last vertex of our rhombus is somewhere on this upper arc. Similarly, if we do the same thing here, start at F1 and do the same thing over here. Okay. And I'm going to do this over here just to make this a little clearer for everyone. There we are. You'll note that when you do that, we have ourselves an intersection point. So in this situation here, this is going to be our step 2. So step 2 sort of creates these antennae-like arcs here. So something like this here. We want this to be the same radius as well. Now, do they have to be the same radius as step 1? I don't know. Maybe you can figure it out. But nevertheless, once we have that here, now we can go ahead and construct this here. Something like so. And that will create the angle bisector we want. And that's going to be step 3 here. So notice our construction is going to look something like this here. And again, notice that the dotted lines I have here, essentially what we did here was just split this dotted line in half. D1 to F1, this point where this dotted line meets the, this point here where it meets the black line here, that's the that's the midpoint here. That's what we want. In this case here, we end up with something that kind of looks like this. So our bisection of an angle should work out something like that here. Again, you see that this comes from the analysis we did here involving rhombi.